Under steady state thermal conditions, the temperature at various locations in a two-plate togometer is shown in the figure as given below. It is a two-plate togometer. If the thermal resistance of the standard bottom plate is 1.5 Kelvin per watt, then the thermal resistance K by W of the fabric specimen correct up to 1 decimal place is. You have to find what is the thermal resistance. So using the induction formula we can calculate this equation. If you know the induction formula, then Q is equal to lambda A T delta T upon D. This is a typical induction formula. Where Q is the heat measured in joule, lambda is the thermal conductivity, A is the area, T is the time, small d is the thickness, and delta T is the change in temperature. So taking all these things as constant, if we write as how these things are related, then we know that conductance is inversely proportional to 1 upon delta T. Okay, because lambda conductance is lambda. So the relation between lambda and T, if we keep all these things as constant, then lambda and delta T, these are lambda delta T is constant. If we is equal to constant, then lambda is inversely proportional to 1 upon delta T. If we keep Q, D, A and T as constant, then this relation can be found out. If the relation between conductance and temperature is inversely proportional, then what will be the relation between T or resistance? Then resistance is directly proportional to delta T, since conductance and resistance is inversely proportional. So if it is inversely, then resistance is directly proportional. Then we can find that R is equal to K into delta T, K delta T. Then R is given out to be, R is 1.5. K you have to find thermal resistance, and change in temperature. Change in temperature between T2 and T1. So 36.9 minus 36.4. 36.9 minus 36.4. So 1.5 is equal to K into 0.5. Then K comes out to be 3. So the value of thermal resistance of the fabric specimen in correct up to 1 decimal place is 3.0. You can write this as 3.0 K, value of K, but it is not the thermal resistance, it is a constant that we have seen. Now thermal resistance is R. So thermal resistance, how we will calculate R? Then R is equal to K delta T. Now again R is K, we have found out 3, and delta T is now difference between T3 and T2. 36.4 minus 34.8. 36.4 minus 34.8. 3 into 1.6, that comes out to be 4.8, and this is the value of thermal resistance, that is R, that is 4.8. It is 4.8 and it is the value of R. So the value of thermal resistance in K by W is 4.8. This is the correct answer. Now coming to the next question. For a wool fiber strand, the relationship between VR and N, average number of fibers in the cross section of the strand, is given below. VR is equal to 112 upon root N. For the above relationship, the CV% of the linear density of the wool fiber rounded off to 2 decimal places is. You have to find the CV% of the wool fiber, whereas VR average CV% and everything is given out to be. So for wool fiber, if you know, for wool For wool fiber, wool VR is 112 upon root n. Root n is number of fibers. Also, in general, VR dash CV percent in general is 100 by root n. So the CV percent of the linear density of wool. So for CV percent, if we need to calculate the linear density of wool, then what would be the formula? CV percent of linear density of wool fiber is would be VR square minus VR dash square. This is the formula of difference in the CV percent by square. So if you know what is the CV percent ka whole square. If it is a square, then it is also a square. Then CV percent square is CV percent CV upon root n whole square is equal to VR is 112 upon root n square minus 100 upon root n ka square. So if you will solve that, then it will come out to be CV percent upon n is equal to 100 will come out to be 112 square upon n minus 100 square upon n. Then if we will take n common, then it will cancel out. CV percent square is equal to 112 square minus 100 square. Then if you will calculate CV percent, it will come out to be root 112 square minus 100 square. It will come out to be 50.43 CV, and this you have to calculate CV percent rounded off to 2 decimal place. Then the answer is 50.43. This is the correct answer. The only thing that you should know that the for wool fiber, what is the CV percent? 112 upon root n. This is a simple formula you need to know, and the difference in how to calculate the CV percent in general for the wool fiber and or any other fiber in general. Now coming to the next question. Now the breaking load of a cotton yarn with twist multiplier as 4 TPI into under root NE indirect count is 2.5 Newton. If the twist number of turns per inch of the yarn is 20, then the tenacity is gram per tex या centi-newton per tex of the yarn rounded off to 2 decimal places is. Then this is very simple. The unit of tenacity is centi-newton per tex. Just calculate the centi-newton, that is yarn force load. Then the load is given as load per tex. Tex means the yarn count. Just divide the load per unit count, then it will come out to be tenacity. Load is 2.5 Newton. If we multiply by 100, 2.5 into 100, it will come out to be 250 centi-newton. And just calculate the yarn count. So how we will calculate the yarn count, because any is not given and TM and TPI is given. So you know the formula, TPI is equal to TM into under root TPI is equal to TM into under root NE. TM into under root NE. So TPI is given as TPI is 20 and TM is 4 into under root NE you have to calculate, then it will come out to be 5. So NE is 5 square is equal to 25 NE. So how to calculate the tex, since we have to calculate tenacity in tex? Tex is 590.5 upon NE. So 590.5 upon NE is 25. So if you calculate, then it will come out to be 23.62. So we have calculated this as tex and this as load as centinewton. Load centinewton. Load in centinewton. Centinewton, and this is count in tex, count yarn count. So tenacity in centinewton per tex is 250 upon 23.62. If you will calculate this, then it will come out to be 10.58 centinewton per tex, and this is the answer. So the tenacity is 10.58 centinewton per tex. So this is the answer. I think you must have understood the basic concept behind all these things. The special things to note is the basics of these things, the basics of units, the basics formulas, and then you can calculate therein and thereafter. Now coming to the next question. Cotton fabric is dyed at 5% shade on the weight of the fabric using a monofunctional dye, reactive dye. Monofunctional reactive dye means only the one functional group of the reactive dye reacts with the fiber. And the next thing that is given is the molecular weight of the dye and the cellulose unit is 400 and 342 respectively. If all the hydroxyl groups in the cellulose are accessible for reaction, the percentage of unreacted hydroxyl group of cellulose remaining after dyeing rounded off to 2 decimal place is. So the thing that is given is molecular weight of the dye is given as 400, and number of hydroxyl group, number of hydroxyl group in cellulose unit are 3 OH groups. So 3 OH groups in cellulose unit, 3 OH group. So the molecular weight of 3 OH groups is 17, OH 16 and 1 hydrogen 17. So 16 plus 1 is 17. So for 3 into 17, that is 51. Since all the OH are accessible for the reaction, since it is written that all hydroxyl groups are accessible for the reaction, then what is the effective weight? So this will react the number of unreacted groups. So this is totally reacted. So molecular weight, effective weight for unreacted would be 400 is the total weight and it is reacted. So unreactive effective weight unreacted का, so it will come out to be 400 minus 51, 349. So percentage unreacted. So percentage of unreacted OH group. So percentage of unreacted OH group will come out to be 349 is the weight and total weight is 351 upon 100. It will come out to be 99.4%. So this is the answer. In 2 decimal place, it is 99.40. Now coming on to the next question. A polyester fabric of 150 centimeter width and aerial density of 300 gram per meter square is printed at the speed of 60 meter per minute. The solid content of the print paste is 50%. After printing and drying, the aerial density of the printed fabric becomes 400 gram per meter square. The consumption in kg per hour of the print paste in integer is. So you need to find the production rate first. Production rate will come out to be, since the aerial density is 300 gram per meter square into 150 centimeter, means 150 upon 100 meter into what is the speed? 60 meter per minute. 60 meter per minute into 60 meter per minute. 60 meter per minute in kg per meter per minute to kg per hour. So if it we take out to be in kg per hour, so for kilometer 1 upon 1000 meter into kilometer, and for minute into hour we need to find write 1 upon 60 into 60. This is r upon 60 into 60. 1 upon 60 r. 1 minute is equal to 1 upon 60 hours. So it will come out to be 300 into 150 upon 100 into 60 into 60 upon 1000 kg per hour. If you will solve, then it will come out to be 1620 kg per hour. Then after printing, what is the production rate? After printing, the production rate will come out to be 400 gram per meter square. So 400 gram per meter square into 150 upon 100 into 60 into 60 upon 1000 on the same terms, just the areal density is changed. Earlier it was 300, now it is 400. So it will come out to be 2160 kg per hour. We have done this to keep the units same, that is the production rate in kg per hour. So if you will compare the fresh one with the new one, earlier the production rate was 1620, now the production rate is 2160. So what is the increase in the fabric weight? If you have done printing, then there is increase in the weight due to the weight of the print paste also, because the print paste also carries some weight. As you can see that the areal density, the GSM of the fabric earlier was 300, and after printing it was increased to 400 as the print paste, and also contains heavy weight. So how much the fabric weight is increased, we can write here. Increase in fabric weight, increase in fabric weight will come out to be, increase in fabric weight will come out to be 2160 minus 1620. It will come out to be 540 kg per hour increase in fabric weight. So, and also it is given that the solid content, the print paste is only 50%. That is only the 50% is solid content paste. So how much will be the consumption of the print paste? Let the consumption is 50%. So the total weight is X into 50% is reacted only, and that comes out to be 540. So when you will solve 540 into 2, then the weight will come out to be 1080 kg per hour. In integer, the consumption in kg per hour of the print paste in integer is, so the answer is 1080. This is the answer. I think by now you have understood how the gate questions are asked and how to solve them. This is not a very typical type of question, just you need to clear with the fundamentals of textiles as well as the basic formulas. You should focus, you should be mentally aware what thing is asked, what thing is given, what to do, and how to focus on numericals, how to focus on the units given, because they play with the units. Because many times the questions, if you just see the units very carefully, then you can easily solve this question irrespective you know the technical fundamentals or not. So just focus mentally, be aware, and I think this gate series will help you a lot. This is the typical solution of a gate 2022 textiles part. I think you have liked this video. Okay, we'll meet in the next video. Till then, keep learning. Thank you.